Objective 3, identify influential observations. An influential observation significantly affects the least squares regression line slope and/or y-intercept. It also affects the value of the correlation coefficient. Methods exist for determining whether a particular observation is influential. However, they are beyond the scope of this course. Nonetheless, we can still get a sense as to whether a particular observation is influential right now. In the activity that we're going to do next, we are going to explore 3 cases to determine which case results in an influential observation. Okay, so let's take a look here. So activity 2, okay, what it's asking us to do is influential observations. So this activity will allow you to discover the circumstances under which an observation may be influential. So we're going to use the applet to answer questions A through B. Okay, so I'm going to first open up the applet here. Okay, and the first thing tells us to click the all data box down here to show the least squares regression line for the data. So when you click on that, it's going to give you the red line, which tells you the least squares regression line for that data. Okay, next in part B, what they want us to do is they want us to click add point. And we're going to add a point. So we're going to add a point, and then we're going to put in x equals 9, comma, y equals 13. Okay? So we put in 9, comma, 13. And so that gives us a point up here. Okay? Now, using the mouse, we're going to click and draw a box around that point, 9, 13. So we're going to draw a box around that. Okay? And then you should see the point change to an X. Okay? And then we're going to check the box not selected to draw the green regression line with the new point excluded. Okay? Do you believe the slope and/or y-intercept change significantly? Okay, and then you record the values of the intercept and slope in the table below the graph. So here is our intercept and here is our slope. So I'm going to go ahead and then copy that so we know what our recording should be for that particular data. So there is our information from the first step. Okay. Now, in part C, we're going to click reset the applet. So we're going to hit reset. Okay. And now we're going to add a point at 14, 15. So we're going to put in 14, 15 and select OK. So there's 14, 15. And again, using our mouse, we're going to click to draw a box around that. And again, we want to make sure that we can see an X around it. Okay. And then check the box not selected, which we do have, to draw a green observation, which it has, regression line, with a new point excluded. Do you believe the slope and/or y-intercept changed significantly? And then we're going to record what that looked like. So I'm going to go ahead and record what that did. So let's take a look at the slope there. Okay, the regression line, 2.79. There is the one that's 3.44. And that's the intercept, and there is the slope. So the slope here in the first one, we can see here that when you compare the two slopes, they're pretty much the same. Over here, it's a little bit different. Okay, now let's go to part D. Okay, and we're going to click reset to reset the applet. Okay. Okay, so now it says using the point, we're going to add a point 19, 15. So we're going to add a point here, 19, 15. And select OK. Okay, so there's 1915, and you should see a point change to an X here. So we're going to go ahead and draw another box around this 1915. Okay, and then again, we have both of those boxes checked. Okay, and then do you believe the slope and or y-intercept changed significantly? So let's take a look at that. Okay, so go back and review again here. So if you look at the y-intercept, it's slightly different. Over here, the slope is slightly different. Okay, now let's take a look at part E. Okay, so for part E, what we're going to do is we're going to go ahead and click reset again. And then we're going to add a point now, which is 20, 8. Okay, and just like we did before with the 20, 8, we're going to go and draw a box around that. So we have an X, and then we're going to see what happens here. And now let's take a look at the slope and the intercept. Okay, so we can see here what's happening with our slope and our intercept. Okay, you can see it goes from 3.44 to 5.31 as far as the slope, the intercept, and the slope is 0.54 down to 0.31. Now, the cases from the previous activity are now shown in a scatter diagram in the figure below. Case 1 is an outlier because its value is large relative to its x value. Case 2 is large over here relative to both its x value and the y value, but follows the overall pattern of the data. Finally, case 3 is large relative to its x value, and its y value is not consistent with the pattern of the data. So, influence is affected by two factors. One, the relative vertical position of the observation, residuals, and two, the relative horizontal position of the observation, leverage. Leverage is a measure that depends on how much the observation's value of the explanatory variable differs from the mean value of the explanatory variable. Using these terms, case 1 has low leverage and a large residual. Case 2, and let's go ahead and highlight that. So case 1, again, is low leverage and a large residual. Okay, case 2 has a high leverage and a small residual. And then case 3, we can say has a high leverage and a large residual. So from the previous activity, you should conclude that observations such as case 3, high leverage with a large residual, tend to be influential. So for example, identifying influential observations. Suppose that our golf ball experiment calls for 9 trials, but the player we are using hurts his wrist. Luckily, Bubba Watson, a professional golfer, is practicing on the same range and graciously agrees to participate in our experiment. His club head speed is 120 miles per hour, and he hits the golf ball 305 yards. Is Bubba's shot an influential observation? So for convenience, we present the data from table 1. Okay, so we recompute the least squares regression model with Bubba's shot included. If the slope or y-intercept of the least squares regression line changes substantially, Bubba's shot is influential. Now the least squares regression line without Bubba is y hat, which is equal to 3.1661x minus 55.7966. The least squares regression line with Bubba included the data set is y hat, which is equal to 2.2287x plus 39.46. So let's go ahead and highlight that information. Okay, so without Bubba, there is the least squares line, which is that green one right there. Okay, and then the least squares regression line with Bubba included is the following. So that's going to represent that line, and that is with Bubba Watson. Okay, so we graph the regression lines with Bubba included, which is the magenta color, and excluded, which is the cayenne, on the same scatter diagram, which you can see down below here. Now the inclusion of Bubba Watson in the data set causes the slope of the regression line to decrease from 3.1661 down to 2.2287, and then the y-intercept to increase from negative 55.8 to positive 39.46 substantially. In other words, the Bubba data pulls the least squares regression line towards his observation. So his data point is influential. Now, deciding what to do about influential observations. As with outliers, influential observations should be removed only if there is justification to do so. When an influential observation occurs in a data set and its removal is not warranted, two possible courses of action are to 1. Collect more data so that additional points near the influential observation are obtained, or use techniques that reduce the influence of the influential observation. These techniques are beyond the scope of this text. In this example, we are justified in removing Bubba Watson from the data set because our experiment called for the same player to swing the club for each trial.